Okay. Well, welcome to Calculus, Spring 2021. My name is Scott Cruzard, University of South Florida. This is quiz review for 1B, which someone has corrected me. Thank you very much. In class, as usual, there is chat in Twitch. There is chat in Blackboard Collaborate Ultra. Blackboard Collaborate Ultra is private. Twitch chat is public. And we're late because I spent 20 minutes talking about the class and 2 minutes fixing the things that I was late for, and 1 minute explaining why I was late, which is totally unhelpful. Okay, the definition of a function. Let x and y be sets. Let f be a collection of ordered pairs from x cross y. F is a function if, for every x and x, there is a y and y, so that the point xy, the ordered pair xy, is an f, and for any distinct x1, x2, y1, comma, x2, y2, and f, x1 does not equal x2. Okay? 1 to 5, how do we feel about that definition? Polling, multiple choice, definition. Okay, so let's break down. There's a question about what you needed to write. Okay, the stuff in purple is the preamble. Okay. The preamble, the light purple here, this is the preamble. This right here is +1 refund if included. Okay? So you didn't have to do it. But if you did it, and then you miss something below, you get a point back. Okay? This stuff here is required. Okay? It's 4 points, so it's going to be 2 points for this and 2 points for this. Now, let's say you forgot it. Half credit for intuition. Every x is used and no x is used more than once. That's the intuition. Now, if you went to the textbook and pulled its definition, if you went to the textbook and pulled its definition, which I had out, and then I put algebra and stuff on top of it, you would have found a different definition in the book. It would have been this intuitive definition that said it's a rule and so on and so forth, and I would have given you half credit for that. Now, what's the moral of the story there? Right, so an expression containing two variables, one independent, one dependent, that's an intuitive definition. You would have gotten half credit for it. Okay? What's the moral of the story? What's the moral of the story about that? Watch lecture, read class notes. Let me put it this way. When I give you a statement of a definition or a theorem, do it verbatim. All right? Book bad, me good. That works too. Now, this is actually the only definition in the entire course where I won't take the book version. Okay? Because the book version only has half the thing and it's a highly intuitive definition. So this is actually the only definition where I won't take the book. However, my definitions are nice and bulleted and everything. So usually you're better off memorizing my definition anyway. Because I put some time in making them so that they're all bulleted. You can remember how many conditions and conclusions there are and stuff like that. My definitions are generally easier than the ones in the book. By easier, I mean easier to remember. Except for this one, because this one is the first formal definition. But the moral of the story is use mine. Okay, now, how do I memorize a definition? I don't. I memorize the picture. These are the pictures that are in my brain when I say function. This is okay. This is a no because I've got two x's going to the same y. And this is a no because I've got an x that's not defined. So when I'm thinking about the definition, this is what I've got memorized in my brain. Right? Every x got used and no x was used more than once. Right? Now, this is a harder definition, right? There's for every x, there exists a y, so that xy is an f. You could have written something like, for every x, there exists a y, so that xy is a point. By the way, this little symbol, someone was asking me about that earlier. This means in. Or is an element of. Okay? Also, you would have gotten half credit for the pictures. And if you drew the picture and then made a mistake, +1 refund if with formal. So if you did this and you did this, you got 3 out of 4. Okay? All right, 1 to 5. How do we feel about how these things get graded? And by the way, I'm not asking how if you like it or not. I'm asking if you understand it or not. No, I hate it. The top pick says okay. Right, I've got 2 points going to 1. That's okay. This, no. That, no. Okay. Does it sound like pretzels? Am I giving pretzel background noise? Okay. All right. I've got a new microphone on order, by the way. Apparently, I sound like a robot. I'm a creepy computer voice. And that's no fun. So, there we go. Now, write an example of a function. I've got A, B, C, and I got 1, 2, 3. And I've got a Jackson 5 song. Now, this is a function. What else would be a good function? Right. So G equals A1, B2, C3. Okay, how about this one? For all x in big X, f of x equals 0. That's a function. I'm sorry, not 0, because 0 is not in the codomain. F of x equals 2. The constant function 2. I could have written that. I could have written this. A, B, C, easy as 1, 2, 3. So I could have done this. That would have been a good answer. This is a good answer. That's a good answer. That's a good answer. That's a good answer. All good answers. Okay? 1 to 5. How do we feel about number 2? Yes, the image actually is a mathematical object in this case. This is full credit. Full. This should be a G, by the way, not a Y. Full. This would have been full credit. Oh, let's see. 1, 2, 3. Oops, nope, those are the y values. A, B, C, 1, 2, 3. This would have been full credit. Heck, this would have been full credit. This would have been nothing, right? That's wrong. But that would have been full credit. Okay? 1 to 5, how do we feel about number 2 there? Is this G B1 a function? No. Why? A was not used. No. B was used twice. All right, number 2, B and C, how do we feel? Yes, B will work fine. Every X must be used, not every Y. All right, X's went unused. Not every X was used. There exists an X such that there does not exist a Y such that X, Y is in G. You could have really gotten fancy if you wanted to. Yes, the tests are free response as well. The tests are just like the quizzes. If you want to do well on the tests, study your quizzes. Sometimes I throw in a WebAssign or two just to keep you on your toes. Okay, I do that a lot, but it's like 75% quizzes and 25% WebAssign. And I don't like to ask surprise problems, by the way. And this semester, I'm the one writing the tests, not somebody else. So the tests, the quizzes, it's not that, it's not that it's not that I made the quizzes with the idea of, only covering the stuff on the tests. It's that when it comes to the quizzes are what I think is really important. The WebAssign is what I think is also important, but not as much as the stuff I put on the quizzes. And then the tests are the stuff I think is really important. I'm writing the tests this year. Those of you who had me last semester, never fear. There aren't any of these surprise problems like there were last semester. Okay. So yes, the quizzes are really the stuff I can't ask in a right, because WebAssign you can only ask so much. I can't ask you free response questions in WebAssign. They got to go on quizzes. So that's why quizzes are going to be more theoretical. There will be computation. Don't worry. All right, so let X, what is F's domain? Well, it's X. What is its target? Y. 1 to 5, how do we feel about that question right there? Number 3, A and B. A. I'm sorry, A, the first parts of A. Update, there we go. How do we feel about those two pieces of it, 1 to 5? How do I know the domain is X? Because I told you. Domain. Target. That's how I know, because I told you. Oh, you can write the specific numbers. That's okay too. You could have written that out. You could have written the domain. Also, valid answers. 0, 1, 2, 3. Target. 0, 1, 2, 3. Also valid answers. It's the set 0, 1, 2, 3. It's the set 0, 1, 2, 3. How do I know? Because I said so. What is the image? Well, I'll take that. I'm going to do that in just a moment. I'm going to write F as a set first because that'll show you what the image is. What's the set? If I write this as a set, if I input 0, what do I get out? Well, I input 0 here. 0 is less than or equal to 1, so I get 0. All right, if I input 1, what do I get? Well, 1 is less than or equal to 1, so I get 2. If I input 3, 3 is greater than, 2. If I input 2, 2 is greater than 1, so I get 0. And if I input 3, 3 is greater than 1, so 3 minus 2 equals 1. How do we feel about part B there, 1 to 5? Oh, there's a new poll, everybody. I just realized that if I hit update, it doesn't give you the poll prompt, does it? You have to go out and get it. Okay, I'll fix, but I'll go back to doing it the other way. Okay. All right. So now we have the set. Let's do the image. The image are the Y values I actually hit, aka the range. What did I actually hit? 0, 2, 0, 1. Or you could have written it 0, 0, 1, 2, also valid. You could have written Y minus 3. If you know what that means, you could have written that. All valid answers. Okay, so 1 to 5. How do we feel about the rest of that part A? Yes, so target and codomain mean the same thing. Range and image mean the same thing. The last one, this one says all things in Y except 3. Right, so the range or the image are the things I actually get to. Now, this range thing, there are books, I don't think any of them are still in print, but there were at one point books that called the range and the codomain the same thing. And then they used the word image for this. Okay? The modern thing is to use range and image as the same thing, and codomain and target is the same thing. So, as I said, there are books that call the range this, and that's why range has gone out of fashion to be image being preferred. But range will do. Yes, target is all possible Y. Images are the Ys you actually used. Okay. Draw an arrow diagram for F. So I did 0, 1, 2, 3 here, 0, 1, 2, 3 here. This right here is the X space. This is the Y space. And I want to draw an arrow diagram. Well, my arrow diagram is going to look like something that is green and a pen, not a pencil. Well, okay, so what have I got here? I've got 0 maps to 0. Oh, that's horrible. There we go. No, you don't need to write X space and Y space. That's just nice. And you're going to see me do that a lot. You're going to see me have X space and Y space because it just keeps track of which one's which. 1 maps to 2. 2 maps to 0. 3 maps to 1. How do we feel about that arrow diagram there, 1 to 5? Stop. Start. Can you draw it the other way around? Can you draw it horizontally? Yes, you can. But if you draw them horizontally, you really should label them. But that is legal. All right. Draw the graph of F. All right. So when X is 0, Y is 0. When X is 1, Y is 2. When X is 2, Y is 0. And when X is 3, Y is 1. How do we feel about that graph there, 1 to 5? Multiple choice, stop, D, start. Okay, why would I get points off if I connected them with a line? Why can I not allow the line? Because those values aren't in my domain. Not defined, right? What is F of 1/2? Hell if I know, it's not in my domain. Doesn't exist. Okay. What is the sine of pi over 2? If you only went, if your X space only goes so far, that's fine. Wait, no, your X space has to go the whole way. If your Y space is missing a value, that's okay. The unused value, that's okay. Sine of pi over 2 is 1. What is sine? Sine is the northiness. Pi over 2, my northiness is 1. Okay. Cosine of pi over 2. What is my eastiness? 0. Tangent of pi over 4. That is the same as sine of pi over 4 over cosine of pi over 4. And hey, they're equal. Okay? 1 to 5. How do we feel about our little trig? How do we feel about that little bit of trig? Do we remember our trig? These are the values, by the way, that I want you to know. I want you to know this one. Know the sine, cosine, and tangent for these values. 0, pi over 2, pi, 3 pi over 2, pi over 4, and what is this? 1, 2, 3 pi over 4. Those are the ones I want you to know. Okay? Name one thing you found memorable from either the last class or the last lecture video. Okay, so that was quiz 1B. I'm going to stop the stream now. And we're going to jump into Discord. Give me just 1 second with, let's see, stop the stream. There we go.